friends, welcome to AK Lectures. In this lecture, we are discussing the question number 23 and 24 from Kset 2018 Physics question paper.
For which of the following values of alpha and beta is the following transformation canonical? So for canonical transformation, Jacobian determinant J must be equal to 1. Now what we are doing is, you have Q and P, a coordinate small q small p, you are moving into capital Q and capital P, which means your capital Q should be function of both small p and small q, and your capital P also must be function of small q and small p. So here there is a small mistake here. This is cos beta p and sin beta p. Okay, so this is capital Q equal to small q power alpha cos beta p, and capital P is equal to q power alpha sin beta p. Now what do you mean by Jacobian? Jacobian is nothing but determinant of dou q by small dou q. This is dou capital Q divided by small p, dou p by dou q. This is dou p by dou p. Alright, now what is dou capital Q by dou q? This is q power alpha into q power alpha minus 1 into cos beta p. Now dou capital Q by dou p, q power alpha minus sin beta p into beta p derivative, simple beta. Now what is dou capital P by dou q? Dou capital P is this one. So q alpha into q power alpha minus 1 cos beta p, sorry, sin beta p with respect to alpha q, right? Yeah, then dou p by dou p, that is q power alpha sin beta p derivative is cos beta p into beta. Now finding the determinant, multiply these two and subtract this one. So alpha q power alpha minus 1 into q power alpha, so alpha into q power 2 alpha minus 1 cos beta p into beta, so beta into cos square beta p minus this minus. Okay, so alpha into q power 2 alpha minus 1 into beta into sin square beta p. Now that's equal to alpha beta into q power 2 alpha minus 1, q power 2 alpha minus 1, alpha beta into q power 2 alpha minus 1. This must be equal to what? 1. Jacobian must be equal to 1. So for this quantity to be 1, q power 2 alpha minus 1, q power 2 alpha minus 1 should be equal to q power 0, which means 2 alpha minus 1 should be equal to 0. So alpha is equal to 1 by 2. Alpha equal to 1 by 2. Just substitute here now. Alpha beta value must be equal to 1. Alpha beta equal to 1. So if which means we already got alpha equal to 1 by 2. So alpha equal to 1 by 2, beta equal to 2. Alright. So Jacobian is 1. So here this is what you have to remember. For this entire multiplication or product must be equal to 1. So individually this must be equal to 1 as well as the first two must be equal to 1. So to remember from the 23rd question, it is first Jacobian. What is Jacobian? And yes, that's it. So what is your answer? Q alpha equal to 1 by 2 and beta equal to 2. So option A. If the spatial and temporal coordinates of two events in inertial frame are x1, y1, z1, t1, and in the next frame x2, y2, z2, and t2, then the following expression remain unchanged in Lorentz transformation. Now, on the right hand side of this screen, what you are seeing is the parameters or the expressions which are invariant, okay, or remain unchanged during the transformation. Okay, so this is first one is delta r square minus c square delta t square. This particular quantity remains unchanged in let me call this as es1, this as es2. Under Lorentz transformation, this s1 in s1 and s2, this first quantity, that is delta r square minus c square delta t square. And what is r square? R square is nothing but x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square, and c square is the constant. This particular quantity remains constant. And the second one, e square minus p square c square, e square minus p square c square equal to m naught square c power 4. This also remains constant. Third one, e square minus b square c square. This is also constant. Dot product of e and b. This is also constant. Fourth one. Fifth one, e square minus b square. This is also a constant. Will remain unchanged. Sixth one, the length of a vector in 4 space. A length of a vector in 4 space also constant under this transformation. So your option is talking about the first expression, that is constant. So x1 minus x2 whole square, y1 minus y2 whole square. So here it is minus. So your option is option B. This is nothing but the first one, delta r square minus c square delta t square. So what you have to remember in this from this problem is these quantities, 6 quantities which remain unchanged under Lorentz transformation. These are the 6 ones.
And now here is your question for practice, the question number 25 from electromagnetic theory, as well as the question 26 also from electromagnetic theory. Kindly solve the problem and comment your answer in the comment box.